Very good morning. We begin with the short titration class. The titration that you have in class 12 is not acid-base. It is a redox titration, which means there is something called as a reducing agent and something known as an oxidizing agent. Just to review, an oxidizing agent oxidizes, means itself undergoes reduction, which means gain of electrons. Whereas when we talk about a reducing agent will reduce others. If it reduces others, gives electrons to others, itself will undergo oxidation. So itself undergoes oxidation. Oxidation is loss of electrons. In your titration for class 12, you have got KMnO4 in both the titrations acting as an oxidizing agent and Mohr salt or oxalic acid as the reducing agent. Therefore, this is your oxidizing agent in the titration, while these are your reducing agents in the titration. Mohr salt, you should know the formula, is FeSO4 dot ammonium sulfate dot 6H2. This is the cause of color. Iron is in the oxidation state of +2. In a +2 state, it would be 3d6. So there are unpaired electrons, because of which this is color. Number 1. This is the cause of crystalline structure. What do we call this? Water of crystallization. So, because of the water of crystallization, this is a crystalline salt. So is true for oxalic acid. There is a 2H2O along with COOH. COOH, the bond should be between the two carbons only. When you talk about oxalic acid, the mass, if you calculate with a COOH and a COOH, comes out to be 90, which would be wrong. For any calculations or solutions, you need to take into account 2H2O, which is another 36, makes it 126U as the molecular mass of oxalic acid. Since Mohr salt is a huge formula, so its mass also has to be huge. If you calculate it, you can do so, otherwise memorize it. 392 is the mass for Mohr salt. KMnO4 is required for all calculations. The mass is 58. U, how does it come? Potassium 39, manganese 55, oxygen 16 into 4 gives you 158 U as the mass for KMnO4. These three masses are to be learned. For the titration, you have two titrations. Either it could be KMnO4 versus oxalic acid, or it could be KMnO4 versus Mohr salt. The basic difference. In both the cases, the burette will have KMnO4. Purple colored solution would always be in the burette. In your conical flask, you would be using 10 ml of Mohr salt or 10 ml of oxalic acid. Under both the situations, you require one test tube full of sulfuric acid dilute. It is a compulsion in both the titrations to use one test tube full of dilute sulfuric acid because you require an acidic medium. The medium is acidic, is not required for Mohr or for the oxalic acid. It is required for KMnO4. The reason being, your titration is because of the MnO4 ions, which is purple in color. This purple colored solution should change to Mn2 positive by gaining 5 electrons, and this is only happening in an acidic medium. So to maintain an acidic medium, the reason is you add one test tube full of dilute sulfuric acid, and it helps you to convert purple colored permanganate ions into Mn2 positive, which is colorless. Just in case you forgot this, or the lab assistant had the concentration of dilute sulfuric acid to be a little lower. In that case, you will suffer here because your MnO4 minus will not change to Mn2 positive, and it has a high probability to change into MnO2. The E0 value, the standard reduction potential value, is very high for this transformation where it gains 3 electrons, and this is brown in color. And in this brown colored solution, you have no capacity to come to the end point, which is only observed when you have an excess drop of KMnO4 purple color into a colorless solution, gives you a light pink. There is no color change if KMnO4 is not reactive. In case you forget this or the concentration is less, if the acidic medium reduces, then in that case you end up in MnO2. This normally happens in a neutral medium, which means KMnO4 can act as an oxidizing agent in acidic medium by accepting 5 electrons, in neutral medium by accepting 3 electrons, and also in basic medium by accepting 1 electron. Your MnO4 minus changes into manganate ion, where the change in oxidation state is this +1, it only gains 1 electron, which means KMnO4 is an oxidizing agent under all situations, acidic medium, basic medium, neutral medium. But we want it to be in this situation so that you can easily reach the end point. A colorless solution will easily show you the end point of an excess of KMnO4 to give you the lightest pink. If it changes to brown or it changes to green, as in this case, you will not be in a position to see the end point. So we do not use any of these situations. We deliberately add the test tube full of dilute sulfuric acid. Acidic medium cannot be maintained with either nitric acid or with HCl. There is a specific reason for it. HCl is easy. If in case of sulfuric acid, if you add HCl, then KMnO4 is strong enough an oxidizing agent. It will start reacting with your HCl first. And if it does that, it will change to chlorine water. An oxidizing agent converts HCl into chlorine water, which is not wanted. So by doing your titration with HCl, if you instead of adding sulfuric acid added HCl, then your KMnO4 will start reacting with HCl first. And then it will react with your Mohr salt. So your reading, which is expected around 10, would easily exceed 15 because KMnO4 is being used for HCl first. In case you add nitric acid we very well know is itself an oxidizing agent, so it will start competing with KMnO4. जो काम KMnO4 को करना है वो नाइट्रिक एसिड भी करेगा, which means what? आपके कोनिकल फ्लास्क में मोर सॉल्ट है और उसके साथ तुमने सल्फ्यूरिक एसिड की जगह पर नाइट्रिक एसिड डाला. नाइट्रिक एसिड इसको पहले ही ऑक्सीडाइज करना शुरू कर. The work which was to be done by KMnO4 by addition through the burette has started to be done by nitric acid. So your reading would be low flow. Hence, this also cannot be used because there is a competition between the two. How do you prepare the solutions? You are normally asked to prepare one of the two standard solutions. Mind you, KMnO4 is called as a secondary standard solution. इसका क्या मतलब? This solution changes with time. आपने जैसा बनाया है वो वैसा रहता ही नहीं. Reacts with the atmosphere, reacts with the container, any impurity, it reacts and leads to the formation of some other compounds, hence its concentration keeps on changing. To avoid that, we never make this as a solution. Your teacher will never ask you to make a KMnO4 solution because you cannot prepare it to perfection. It would keep changing the concentration. So your standard solution, primary standard solutions are either Mohr salt or oxalic acid. Any of the two can be asked to prepare. The normal formula that we use is molarity is equal to moles of solute upon volume of the solution in liters. Is the formula that you are very well aware of. किसका solution बनाना है? या तो Mohr salt का या फिर oxalic acid. जिसका भी बनाना है उसकी molarity तो दी हुई होगी. Normally बेटा Mohr salt के लिए 1/20 m दिया होता है और oxalic acid के लिए 1/40 m दिया होता है normally. But there is no rule. They can change it. You can be asked to prepare a different solution also. So don't learn up the values. Supposing I ask you to prepare n/20 Mohr salt solution. So this becomes 1/20 moles of the solute. What is the solute? Mohr salt. Mohr salt का weight मालूम नहीं. Molecular mass तो मालूम है. Volume of solution कितना बनाएंगे? ये बात डिपेंड करती है आपके लैब में ये बर्तन कौन से साइज का है. इसमें एक कट मार्क होता है यहाँ, हमारे लैब में ये 100 ml का है, बट देयर आर स्कूल्स जहाँ पे ये 250 ml का भी होता है. We use 100 ml, so your volume is 100. What's missing? 1000. Because you require it in liters. तो ऊपर ये 1000 लीटर जाए. Only then you do the calculation. Your aim is to find out W, which can be done. You wait and then use it for preparing the solution. There's one more catch left. Once you have weighed, let us take this comes out to be 1.96 grams. If it comes out to be 1.96 grams, after weighing, you need to use a funnel. To this, you add the salt and then you add dilute sulfuric acid. How much? 5 drops, 10 drops, 1 ml, doesn't matter. Once the salt is added, dilute sulfuric acid has a specific function to prevent hydrolysis of ferrous. Your ferrous should not form a hydroxide of ferrous or ferric. To prevent this, we require an acetic method. So, this dilute sulfuric acid, which is added around 1 ml, is to prevent hydrolysis of the molar salt. This dilute sulfuric acid is not required if you are preparing oxalic acid solution. The only difference when you prepare oxalic acid solution would be that your values here would change and you do not require the sulfuric acid solution. Normally the molarity given for oxalic acid solution is 1/40. The mass that you use is 126. This is dependent on your apparatus, what you need. Hence, we prepare the solutions, standard solutions of either molar salt or oxalic acid in this way. Fine? No problem?